All right, here we go. It's our new unit. We're starting off, this is a unit focusing on exponential functions. But we're going to start with what you guys know, which is linear functions. And so that's what our first couple of examples are going to be. And then we'll kind of transition that into exponential function. So a linear function makes a straight line. It's either adding or subtracting the same thing each time. So it says fill in the table. So you run a business making birdhouses. You spend $600 to start your business, and it costs you $5 to make each birdhouse. Okay, so now we have to fill out our table. And we're going to start off with we want a total cost of building a birdhouse. So the first birdhouse, so we're going to start with $600 to start the business. And then our first birdhouse costs $5. So that's actually $605. Okay, and so the second birdhouse is another $5. So that's $610, and then $615. And you can see how each time it's adding 5. Okay, so $620, $625. $630, and then $635. So I guess the question is, what could you write the equation for this? So your function of the number of birdhouses would equal 5, the cost of $5 times the number of birdhouses plus your original $600. Okay. And then our next example, it says you make $15 payments of your loan of $500 at the end of each month. So it's not how long is it going to take you to pay off. We're asking just for filling out your table. So at the end of 1 month, you have made your first payment. So your starting point is actually $485. Then you're going to subtract $15 at the end of the second month. So that's $460. And then the end of your third month, subtract another 15, so you're $445, and then you're at $430. So each time you're subtracting $15. So your bill or your loan balance goes down by $15. Okay, so our function of this one would be f of n equals, and we're subtracting $15 each time. Okay, so the number of months times the negative 15, and then we're starting at $500. Okay, and we're going to eventually get to 0. Okay, so next one, if we're going to graph our functions now. Okay, so we have our, let's see, graph the ordered pairs from the tables below on the given graphs. Okay, so 0, 3. So we're going to count 0 and then up 3. And then over 2 and up 7. So 1, 2, 3, 4, 5, 6, 7. Okay, and then we have 3, 9. So over 3 and up to 9. So that's at 7. Okay, there we go. And then we're going to have 5, 13. So 1, 2, 3, 4, 5. And then 5, 10, 15, 13. Okay, and so we're going to, let's write the equation out here. Okay, so it's just like what we did before. I'm going to write it in function notation. So actually, I'm going to write it in, well, our graph actually says x and y, so I should use non-function notation. So y equals, well, our slope is up 2 over 1, so that's 2 over 1, so 2x, and we started at 3. Okay, our second one, I'm going to let you do the second one because I want to get going on in our video. I don't think we have to go over everything. So you would do something similar to this one. But that's kind of old stuff. This is prior knowledge still. So I really want to get kind of going into the new directions. Okay, so the thing that you got to pay attention to, what we've given you here, it says given that f of n equals 8n minus 3. Okay, so this says f of n, and this says g of n. So you've got to pay attention to which function I'm asking for. Am I asking for f or am I asking for g? And then we can substitute in our n there. So we have 5n for n, and so we have 8 times n is 40, minus 3 is 37. So I have g in for 5 of n, so 3 times 5 is 15, minus 10 is 5. Okay, so negative 4 in for f, I'm looking at f, so 8 times negative 4 is negative 32, so minus 3 is negative 35. Okay. Our next one is g of negative 4, so I'm looking at g, so I have 4 times negative 3 is negative 12, minus 10 is negative 22. Okay, I'm going to let you guys do the last three. They're the 0 and 1, so that's pretty straightforward there. Okay. All right, let's flip it over. Let's start getting into pattern recognition. Good news, you guys are all great pattern recognition tools because you're human. Humans are really great at recognizing patterns. So we have 2, 4, 8, 16, 32. So what's happening each time? So some people might say, well, they're adding 2, but 4 plus 2 is not 8. But 4 times 2 is 8. And 2 times 8 is 16. And 2 times 16 is 32. So 32 times 2 is 64. And then 64 times 2 is 128. Oop, not 125, 128. And then 128 times 4 is 256. Okay, so what's happening here? So I have 16, and then I've got 50, and then I've got 34. Okay, and then I got 18. So this one's actually subtracting by 2 each time. So that's going to be 2. 18 minus 16 is 2. 2 minus 16 is negative 14. Okay, so each time we're subtracting 16. So this is negative 30, and then negative 46. Okay, so it's your job to figure out what's happening. Is it being multiplied? Is it being subtracted? Is it being added? What's happening each time? Okay, so now we have our sequence here. We can start looking at exponents. So we're finally into exponents. So we're finally getting there. Okay, so we have 3 to the third, 3 to the second, 3 to 1. So that would be 3 to the 0, 3 to the negative 1. So it's counting down. 3 to the negative 2, 3 to the negative 3. That's 4, okay? And then 3 to the negative 5. Okay, so then evaluate each term. So 3 to the third power is 3 times 3 is 9, times 3 is 27. Okay, so 3 times 3, the next one is 9. The next one is 3. And then anything to the 0 power is always 1. And then we have to the negative 1/3. So you can see how we're dividing by 3 each time, right? So 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 1/3. 1/3 divided by 3 is 1/9. Okay, so you guys see kind of a pattern here. So 27, 9, 3, 1, 3, 9. What do you think is next? That's right, 1 over 27. Okay, and then you have our next one is 1 over 81, I believe. Yep. Okay. So that's the pattern you're looking for. Okay, so the next one we have 4 to the negative 4th. Well, the negative exponent is actually a fraction. So 4 times 4 is 16. And then 16 times 16 is 256. So this is actually 1 over 256. And then the next one is 1 over 64. Okay, so each time we're dividing by 4. And then 1 over 16. I guess we're multiplying by 4. 1 over 16. Okay, so I want you to try to figure out that pattern, and then once you get to, I'll give you your hint here. So we've got 1, 2, 3, so 1, 2, 3, and then we've got 4 to the negative 1, and then 4 to the 0, and then 4 to the 1, 4 to the 2, and 4 to the 3. Okay, so you guys should be able to figure this one out based on like how this pattern is happening. And your hint here is going to be that 4 to the 0, anything to the 0 power, if you look up here, anything to the 0 power is 1. Okay, so you should end up at 1 right here. So there should be a space here. Something goes here. It'll be a fraction. And then you're going to have the other side going over here. Okay? All right, list 3 terms in both directions. So you can see that it's starting to go both directions now. So this is 2 to the second, 2 to the third. This one's 2 to the negative second, 2 to the negative third. Okay. And then our next one, Exponents is repeated multiplication, so we've got 1, 2, 3, 4, 5. 6 is being multiplied together, so that is actually 6 to the 5th power. Well, there's 3 4s being multiplied, so it's 4, and I want you to write to the what power here. Same thing with this one, 15 to the what? Okay, and then 1/3 to the what power, okay? All right, and then down here, you're gonna evaluate the expressions on the last bit, okay? Okay, so that's pretty much it for this video. I'm gonna let you do the worksheet on exponents in class. It's a pretty straightforward exponent worksheet. You've just got to start looking for the patterns. It's really similar to what we're doing here, and that's it. Good luck.